Hello and welcome back to another video. So in this video we are going to see another technique in differentiation, which is what we call the chain rule. And chain rule is simply a technique used to evaluate functions of a function, which we call composite functions. So in this video we are just basing on that. And when we talk of composing function, we can say, let for example y equals to g f of x. Okay, y equals to g of f of x. You see, f of x is a function inside g, so this is what we call composite functions. So how are we going to find the derivative of these functions? We simply apply chain rule. And how do we apply chain rule? We simply let what is inside to be a certain variable. So we will now say u equals f of x. If you say u equals to f of x, then you will find what the derivative of u with respect to x from this, and you note it down, and then you come back and you replace now your u here. Then you now get your g, instead of f of x you'll be having g of u, and you will find now your dy on du from here. Okay, and we'll do an example below. So we can now say that from this we can now conclude that dy on dx, that is we are interested in, will now be equals to dy on du multiplied by du on dx, the one we got up here. We combine these two. Okay, and when we talk now chain rule, the name is coming simply because of this. Please look at this. This is this arrow, this diagonal relationship. We call that is where the name comes, chain rule. This is this diagonal relationship, the relationship here. We call it chain rule, and this can be extended. We can move, maybe we can say dy on dx to be equals to dy on du times du on dp times dp on dt times dt on dx. Okay, you still see this relationship. You see du and du, you see dp and dp, they are diagonally identical. Dt and dt, they are diagonally identical. At the end we are just simply having our dy here and dx. The rest is as if they have cancelled, but they are not cancelling. So let us begin with one example to see how this works. So we begin with the first example, that y equals x to the fifth plus 1 all that squared. Well, this one somebody can go and expand it like this before finding the derivative, but in this video we are not going to expand it. We are going to use the notion of chain rule to find the derivative, and we can still expand it to compare our results. So let me write it down there. Well, that is squared here. Okay, now we're having y equals to that. So what I will do, I will say u equals what is inside the function, so x to the fifth plus 1, and from here I'll find my du on dx, since u is a function of x only. Now remember that the derivative of x to the n is simply n x to the n minus 1. That is, you bring down the power down, then you subtract the power by 1. Okay, now we go. So 5 is our n, so that means 5x to the power 5 minus 1. The derivative of 1 is a constant, is 0 plus 0, and this gives us 5x to the power 4. 5 minus 1 is 4. So that is now my du dx. But now what comes y? Y now becomes u squared, because I will not just come inside this one. U is x to the fifth plus 1. If I put back u here, I'll just get u squared, and then I'll just come and find my dy on du, which will now be what? I'll bring down the power again, 2, and I'll write u 2 minus 1, which this becomes 2u to the power 1, or 2u. But remember, we are working with x's, so at the end you come back, you substitute your u. You just simply put 2 into what is our u? Our u is simply x to the fifth plus 1. So that is our dy on du. Now applying chain rule, which says that it will be dy on du multiplied by du on dx. We just come down and we just simply write our dy on du will now be equals to dy on d. What am I saying? This will be dy on dx. That is what our goal. Dy on dx will be, because dy on du times du on dx, and dy du is simply what we got to be 2x to the fifth plus 1, 2 into x to the fifth plus 1. All that we multiply by du dx, which is 5x to the fourth. This is it here. Du dx, 5x to the fourth. 5x to the fourth. I can go ahead and open the bracket. So 2 and 5 is 15. I can write it outside. Now take x to the fourth multiplied by x to the fifth, we get x to the ninth. And then x to the fourth times 1, we just simply get plus x to the fourth. And if you like, open the bracket and say 15 x to the ninth plus 15 x to the fourth. And this is our y prime or dy. This is our y prime or dy on dx. You know, y prime still means dy on dx. So this is how we apply chain rule. Let us move to the second example. The second example, okay, in this other example, we are just having this. I unpause the video. So y will now be equals to u to the 10. I will let u to be equal to 2x plus 1. And from here, my du on dx will simply be 2 as a derivative of 2x, which will just be the coefficient 2. The derivative of constant is 0. So this gives me only 2. And the dy on du will be equals to 10 comes down. Then u to the 10 minus 1 or u to the 9th. U to the 9th. But remember, we are working with x, so we are having 10 into u, which is 2x plus 1 all the way to the 9. This is u here, 2x plus 1. Okay, is that u there? Okay, now if we come down to find out our dy on dx, which will be equals to dy on du times du on dx, which will just be simply 10 into x squared into 2x, 10 into 2x plus 1 to the 9th multiplied by my du dx, which is simply 2. Or we can say this is 20 into 2x plus 1 to the 9th. So you see how chain rule is a very simple technique that we can use to find the derivative of a function. Hadn't been there was no chain rule, what you could only do is just to expand this 10 times. That is 2x plus 1 into 2x plus 1 10 times, and then open it before you come to find the derivative, the way we did for polynomials. By the way, this is a video under a certain playlist. Feel free to go on the playlist and discover other videos on product rule and quotient rule that we have already seen, and on loss in differentiation and so on, first principle and other things. Thanks for watching, and in our future videos we will see more on this. So we have groups that we are helping all African students, no matter where you are. Free online classes. You can join with your by contacting the WhatsApp number that you see on the intro of this video to attend those classes. Very important. It is free of charge. So thanks very much and see you there.